Hi, my name is Noah, and I am here with my group to discuss the intricacies behind data engineering. But first, let's meet the team. With us, we have Carly and Morgan, then myself and Caden, all of us fourth years and all with a marketing concentration. So, what is data engineering? The goal of this set of operations is to pull complex data sets from varying sources of information for the preparation and purpose of making said data available for access and analysis. This data is necessary for preparation due to a differing array of data infrastructures within an organization that do not produce uniform data. To further explain this, here is a brief explanation of how data engineering is implemented.
Let's have a look at how data engineering works. Okay, imagine a team with an application. The application works fine, traffic grows, and sales are selling. They track results in Google Analytics, the CRM, an application database, maybe a couple of extra tools they bought to spice up quarterly PowerPoint. And of course, there's this one quiet guy who's the absolute beast of Excel spreadsheets. Analytics, great. At this point, their analytics data pipeline looks like this. There are several sources of data and a lot of boring manual work to move this data into an Excel spreadsheet. This gets old pretty fast. Well, first, the amounts of data become larger every month, along with an appetite for it. Maybe the team will add a couple more sources or data fields to track. There isn't too much data when it comes to data analytics. And of course, you have to track dynamics and revisit the same metric over and over again to see how it changes month after month. It's so 90s. The days of the analytics guy start resembling the routine of a person passing bricks one at a time. There's a good quote by Carla Geiser from Google. If a human operator needs to touch your system during normal operations, you have a bug. So, before the guy's burned out, the team decides to automate things. First, they print the quote and stick it on the wall. Then, they ask a software engineer for help. And this is the point that data engineering begins.
This data is set up by data engineers to be available for analysis across differing data infrastructures within an organization. Now, let's go over the brief set of steps of how this is accomplished. First, through automation, data is run through an ETL pipeline. But what does this mean? Data is extracted from its multiple sources. Then this data is transformed to match a similar format, making the data uniform with each other. And finally, it is loaded to a main storage warehouse where it is more easily accessible.
Now that we know what data engineering is, let's take a look at how it has developed over the years. The original conceptualization of data engineering can be traced back to the late 90s. At this time, data engineering was one of the technologies and techniques just emerging surrounding mass data. IT departments still owned everything related to data, and at this stage were focused on using simple ETL along with managing data movement through warehouses and databases. While they were finding new ways to maintain data and build infrastructure, the ability for other teams in a company to utilize this data still had a long way to go. Throughout the early 2000s, mass digitization grew, and so did the demand for data. Teams outside of the usual IT department began to have a greater desire to access and control relevant data. At this time, the right tooling and processes were not yet in place to allow other teams to access data in a timely manner. The IT department was still hard at work laying the groundwork of pipeline infrastructure, in-memory databases, custom integrations, and early ETL solutions. Eventually, data engineers would build off this work. Around 2010, FANG companies drove innovation by using customer data across disciplines. This time period saw significant advances in tools used for data flows and unification. Companies like Redshift and Snowflake were born, advanced data workflow tooling became common, and the cloud was becoming widely adopted. While FANG companies had the money to spend on great data engineering programs, smaller companies had a harder time accessing resources to reach their data engineering goals. This led to a large demand for affordable software that could support these new goals. From this demand came two key ways to control and tool data: powerful all-in-one suites and endpoint solutions. During this time, the software industry was booming and the marketing technology landscape expanded. As you can see here, the number of tools grew from 150 to over 5,000 by 2017. The growth of these tools allowed teams to get data faster and create more value. In the late 2010s, the amount of accessible data continually growing, combined with the demand from teams to have access to any data they want, led to the introduction of self-service analytics, a technological advancement allowing teams to access data on their own. The innovation was great until companies faced challenges due to a rapid increase in individual tools and data sets across multiple teams. This caused a crisis of integration. Teams and entire businesses had to decide between being disconnected and siloed, best-of-breed tooling for individual teams, or software suites that centralized all data but were not warehouse friendly and had far less advanced capabilities. From these problems, modern data engineering was born. Data engineers set out to unify and make use of the mass amounts of data. Empowering teams with the best tooling while maintaining a unified, flexible data layer has become a central technique and operational challenge for almost every business. Data engineers are at the center of the action. Data engineers have worked hard for decades to collect and connect at the data layer in the warehouse. Having this solid foundation allows for teams to try new innovative tooling with little risk. With over 9,000 solutions on the marketing technology landscape today, there are many ways companies with connected data can continue to analyze data. As you can see here, data engineering is a growing field that is gaining interest among the public. You can see this from our Google Trends search and the growth of data engineering.
Now that we understand what data engineering is and how it has evolved over time to become the powerful tool that it is today, let's take a look at a couple real-world applications that leading companies are using now. Two of the major players in this field are Snowflake and Amazon Redshift, which are both cloud-based data warehousing platforms using data engineering tools to bring impactful insights to businesses about their companies and customers. We'll start with a closer look at how Snowflake brings value to its customers. 241 is the number of Fortune 500 companies that utilize Snowflake's cloud-based services, and 488 is the number of Global 2000 companies that use Snowflake services. So as you can see, Snowflake is a super commonly used warehousing platform that many large companies across the globe and many sectors utilize, and is offered in the popular coding languages Python, R, and JavaScript. Snowflake is a company that takes data storage, processing, and analytics to the next level by making them faster and easier to use, as well as improving scalability and flexibility compared to traditional methods. It does this with its well-designed three-pronged structure, including data storage, query processing, and cloud services, and by automatically sizing resources to optimize costs while maintaining a quality performance. Snowflake's main uses for a company include integrating data streams from two or more sources into a single database and managing infrastructure in order to gain more powerful insights and make better predictions about relevant customers. But more than anything, Snowflake saves time. And with that time, the company, and especially the data engineers, are able to focus on building more streamlined data pipelines, which add more value to the company than traditional methods. These tedious, data-heavy tasks, which could typically take weeks, can now essentially be done automatically with the power of Snowflake. And some of the companies that are recognizable using Snowflake today are Capital One, Chime, JetBlue, and Anthem. Our next example, and one of the major competitors of Snowflake, is the Amazon-built data warehousing platform Redshift. As a direct competitor, Redshift and Snowflake have similar functionality, intelligence capabilities, and goals they help companies achieve through using the software. Both platforms allow companies to scale data analytics and leverage the insights gained from the analysis into more accurate predictions about customers, market trends, and/or business operations. And all of these are being done faster and in a more cost-effective way than ever before. With this improvement in analytics, companies that implement platforms like Snowflake, Redshift, or any other data engineering tool that fits their business needs can gain a serious competitive advantage in today's data-driven world. And some improvements they can potentially see as a result could include more effective decision-making, higher quality customer service, and increased bottom lines. Both Snowflake and Redshift offer top-of-the-line data security and can store structured, semi-structured, unstructured, and even streaming data sources, offering high levels of flexibility to their customers. So while the two platforms have a lot in common, there are a couple key distinctions to look out for when deciding what is right for your business. One main difference is query processing speed, and Redshift outperforms Snowflake in this area, largely in part to its leveraging of PostgreSQL to handle nodes with denser storage, allowing faster query return speeds on large datasets. Redshift also provides a little more data customization capabilities than Snowflake, and for companies that already have other systems in place for Amazon Web Services, Redshift provides seamless integration into its service ecosystems. Snowflake, on the other hand, sees a lot of its value come from its ease to implement and manage without sacrificing performance like some of its less powerful competitors. Snowflake's cluster processing is completely automated and requires no manual maintenance once implemented, whereas with Redshift, some routine manual maintenance is required. On a similar note, Snowflake's platform can scale itself automatically, whereas with Redshift, adding or subtracting nodes is required for scaling. Both of these maintenance strengths allow Snowflake to be implemented and managed at a lower overhead cost than Redshift. So who's better? It really comes down to the individual needs of the business, making the decision and whether or not they're interested in the more data customization and faster query processing power that Redshift offers, or the lower maintenance cost and ease of scalability that comes with using Snowflake. Either route a business takes, they are sure to get a powerful data warehousing platform that will bring them invaluable insights about their company and its customers, all faster and more cost effective than ever before. And so finally, a couple key takeaways. Basically, the entire goal of data engineering is to make accessing, storing, and analyzing large data sets easier and faster. And with the improvements in technology today, this is becoming a lot easier, and the field itself is growing a ton. A lot of new jobs are being created. And by implementing these systems in the correct way, companies can create sustained long-term impacts for their businesses.